way. You can't use this specific set of tools to make other games. You have to only make this game and maybe some small things around it. So this is the level editor. So it's like the only like UI that I can show that resembles an engine. But I think the important thing to remember there is that when you are making your own game, you just have to make the game. You don't have to make any tools that you're not going to use. So the whole, like, coming here, a lot of people have been very impressed by the fact that I made an engine, but like I didn't make Godot, right? I didn't write millions of lines of code. I wrote a few thousand lines of code and made a game. So it's just something to keep in mind that it's not as scary as it's sometimes made out to be. So of course, there are like a lot of benefits that I think to making your own engine. So the first one is flexibility. You are free to do things the way that you would like to. So once, like all engines have an idea of how games should be made, either explicitly or implicitly, that you have to use nodes or you have to use prefabs or whatever other things call it. Then there are specific ways that you integrate your assets into your game. But again, like here, you have the flexibility to do things that you want. In some cases, that means you can make things that are very difficult to make in an engine. So for example, a game like Noita, Dwarf Fortress, Factorio, things like that are maybe not possible to make in an engine because their constraints are so different. Secondly, there's a lot of freedom that, at least for me, like I love writing code. So I can explore different things, different ways of doing things, different tools available, and how to integrate them with each other and with the game, right? So it's a exercise in having a lot of freedom. And finally, it's a lot of fun, right? So I'll tell you guys a secret. I'm not passionate about making games. I'm passionate about writing code. And like making games is just an excuse to write some code. So those are the benefits. And of course, there are a bunch of drawbacks as well. So I think the biggest one for me has always been coordination issues. So since like the whole engine and pipelines are all written by me, it becomes very difficult to have other people work on the game along with me unless they are also equally familiar with the tools, or I have to make special pipelines and workflows just for them to add their things into the game. So that's something to keep in mind, that it could be a drawback based on what your team is. Secondly, like there's a lot of complex tech and a lot of things go wrong, and there isn't as much good documentation for integrating like small features of OpenGL as there is for like maybe Godot or Unity. So sometimes you fall into these very big morasses, and you know no easy way of getting out of it. So that is definitely an issue that you face sometimes, but it's a part of the fun, right? And finally, like tooling, I think, again, you have to, everything that you need, you have to put in yourself. Like engines generally come with things like profilers and frame views and things like that, which you can easily use to see when something's going wrong. But when you're making your own engine, then once something goes wrong, then you have to go through the whole process of integrating some form of tooling to figure out what actually happened. And that could be an issue. But again, like for me, these are fun, right? Like I enjoy the process of the architecting the games and understanding how different things work together. So I enjoy it. But that said, if you've not made a game before, then I think that people worry too much about this question, right? Which engine should I use? Should I write my own engine? Like making a game is a lot of work. It takes a lot of time. It takes a lot of determination, a lot of mental fortitude. And this single decision seems to step so many people up, right? That they get stuck at this, which is literally this at step 0. So like just do whatever feels right. Like make a small game, and then you have a better frame of reference to decide what you want to do for your future games, right? Don't get stuck at this stage. So with that said, let me talk about more about my game and the basic stack it was implemented upon. So I used SDL for platform things like opening windows, getting graphic contexts, reading inputs, playing sounds, things like that. I use OpenGL for most of the graphic stuff. I use very little of OpenGL, but that's the library I happen to use. And I use a language called Zig, which is very similar to C. Like I really like C, but C is also very old and it has some decisions that are outdated. So like Zig is one of the languages that's out today that kind of sands off those edges. But again, like these are not better or worse than anything else in my opinion. It's just what I happen to use, and you should make these decisions yourself. And there are not too many wrong decisions, like most things work pretty well. So don't worry too much. Let's talk about some of the things that making my own engine got me. So like this is, I think, my favorite feature. It's a custom vector rendering pipeline. So the game looks like this. So it's not made using PNGs or anything. I have my own whole tool and pipeline for creating these vectors and rendering them. So yeah, can you play the video? So this is the tool and me using the tool to do some of the things. So as you can see, like these things, the sails move slightly in the wind and the water shadow like moves slightly along with the waves. And that's all done with a very simple system where like this is the tool that I wrote. So you can like move these shapes around. And also for each vertex in the triangle or in the shape, you can define how the noise is going to affect it, right? So that's the effect that's being created using this pipeline. So back to the slide. Yeah, so basically it's just like data. You have these vertices as you would in any vertex, any vector creation program. And you send that to the vertex shader. And in the vertex shader, for every vertex, we add noise along a certain direction, right? So as you saw last time in the demonstration of the tool, we'll see it again. But you can decide exactly which direction each vertex is going to move in. And that means that you can decide how things look, right? So when you have a sail that is just a triangle, when two ends are fixed and one is moving in a meaningful direction, it gives the illusion of like movement. And this whole thing, yeah, you can play the video. Yeah, and this whole thing is like a very powerful way to get life out of a very simple set of data, right? So creating these vectors doesn't take that much time, and using this feature gives it the certain sense of life, as well as it works in the context of the game where you need things to be clear. So it doesn't distract. Like over here, obviously, in this demonstration, things move a lot around, but in general, it doesn't distract from the game itself, but it still makes everything feel alive. So yeah, video is done. So along with these movements, there are also some other very basic things that you get. You can play the next video now. So since I have this whole tool and this whole pipeline, I also got some additional features out of it. Next video, Wasim. So yeah, here you can see that one ship is facing left and one is facing right. And the ship needs to turn from face one way to the other. Right, so rather than just snapping between the two, since I know all the data about all the vertexes, you can like smoothly lerp between these things, right? This is like a linear interpolation that runs from each start vertex to each end vertex. But it's because I have all the information that I need and all the data, you can have these like really smooth and cool looking animations without having to put the effort to actually animate it, right? And again, that thanks, Wasim, that's done. So again, that comes down to knowing the tools that you have and using them to the best of your capability. So making something like this in other tools is possible, but you'll have to do a lot of work around adding like this vertex direction movement and this interpolation within like Inkscape or Illustrator or whichever other vector tool you use. But since I created this tool myself, I could do a lot of things. And additionally, in the tool itself, I can see exactly how it's going to look in the game because the same code that runs in game runs in the tool. So I can see exactly how the animations are going to look. So yeah, the next feature is brute force puzzle solving. So yeah, Konkan Coast Pirate Solutions is a puzzle game. So I wanted to make sure that I know all the possible solutions to a level, and there are no solutions that I don't intend for, right? So, and that is allowed, like I did this by using the architecture. So basically the architecture of the game is you have the central portion, which is called the sim engine. It has the ships and tokens, and it has the simulation, and it can figure out whether the level has been won or lost, right? And around this, you have the rendering data, the positions of the ships, the animation things that we just saw. All of that exists outside of the core data of the ships alone. And outside of this, you have controls to actually allow the player to play the game and interact with all of the things. And I think this architecture is different from most engines where generally you'll have all these three things together, that you'll have a single entity which will have its meshes and its animations attached to it, as well as how control should affect that entity, and it'll all be in one place. So then now if I want to run a solver, I can just run the sim engine alone and not have to worry about how the rendering works and how the controls work, because this piece is kept separate. And similarly, I can run a bunch of these things. And so when you say brute force, you want to try every possible solution to the every level. And that's only possible, I mean that becomes much easier and much more traceable once you have a very small core that you are going to be looping over rather than the whole game. Finally, the next feature is input recording and replay. So this is especially useful when you have these small animations and small visual effects that you want to do over, like you're working on them and you want to make small inputs. So there's a way to easily record them and replay them. So like this is how most games do input handling, that every frame or every tick you poll for inputs, and then you update the game based on the inputs, right? So that's how like every game engine generally does it. So in the middle here, I added one step between polling and updating, right? Which is I process the inputs. Initially, it was for like keybind logic, which means that whether you press W or up arrow, the same thing should happen. So I kind of like equated them to be the same. But then once I had this, I also realized that I want to do this whole input automation thing. So I could also save and load them to file. So now what happens is when the game is running, I can, rather than taking inputs from the player or from the hardware, from the keyboard and mouse, I can load them directly from file, which means that I can play a very small series of inputs on loop or repeatedly just to make sure that certain bugs are fixed or certain animations are, or effects are working the way that I'd like. Right? And that was like very useful, especially when working on small polished things. Rather than making a small change and then having to do 15 minute mouse moves, you can like quickly record that and replay that. So yeah, these are the main engine features. And I think none of them are impossible otherwise, right? Like none of these things are not possible in another engine. Like this whole game could easily be made in Godot or WebGL or I don't know, like Web HTML5 canvas, right? So there's nothing very detailed about this game that requires a custom engine, which is generally frowned upon. But for me, I also know that this game wouldn't have existed unless I had written it this way. That the whole idea of this vector animation came because I was looking at the vertex shader and wondering what else can a vertex shader do, right? I already had architected the core of the game to be separate. So when it came for me to have to try to make a brute forcer, then it became much simpler rather than figuring out how to run multiple instances of the game. And similarly, this input recording again came because I already had keybind logic. And right there, I could clearly see that this is the position where this feature needs to go. So I think it was, for me, doing this made the game better. And that's probably why this is the way I make games. So yeah, let's talk about some implementation tales. So I think all like people who love tech love this serialization. It's such a crunchy thing, right? Like you can account for each bit and each byte and figure out how it's stored in data and how it's managed. So initially, my serialization was done using this framework that's made by Media Molecule, which is like this very tight binary framework where, binary serialization, where it has a bunch of features, but essentially it gives you very performant serialization and deserialization, as well as very small files. But at some point it crashed for me and I could not figure out why. And I couldn't load my levels and couldn't load my old files. And then I got frustrated and I just decided to use JSON because every language has good support for JSON, including Notepad. So I could easily see what's actually happening in the game. So I switched to JSON and then I never went back because I realized that I didn't need something to be fast and performant when it's already, like even the JSON version is fast enough and performant enough for me, right? So that's the tale of serialization. And then the next one is sound mixing. So I did my own sound mixing. So sound mixing is when you have two sounds that play together. How do you make sure they don't either destructively interfere with each other or clip or have any bad effects when played together, right? So I started looking at all of the solutions to this problem, but then I remember the serialization story, and I know the whole game, right? I know exactly what are the sound effects that could play together, how many things could be playing at the same time. So I just played them at the same time and listened to it, and it sounded perfectly fine to me. And I tried a bunch of different combinations, and everything sounded fine. So I didn't have to do anything complex for sound mixing because this game doesn't need anything complex for sound mixing. And finally, asset streaming. I think you probably know where this is going. Like, according to Windows Task Manager, this game is 100 MB. So what are you gaining by asset streaming? Like, asset streaming is useful when you have a large game and you're running out of RAM. Whereas this is never going to run out of RAM. So I never even bothered to think about it because, again, like, I learned that I get to make the things that I need rather than having to make everything. And yeah, so I think that's the main principle that I follow. And it's, yeah, I'm not going to swear on stage, don't worry. So yeah, keep it simple, stupid. Sorry. But it's not just simple. It's about, I think there are 3 kisses, as I like to call them. So the first one is definitely simple. Like, use simple tech. I think people who write code like really enjoy these like very specific and crumbly algorithms which like do like magical things and are useful for things like live reloading shaders and entity component systems and having multiple embedded languages running at the same time and interfering with each other and things like that. Like, it just, as a technical person, it's such an interesting challenge, but I've learned that it's better to just keep things very simple. Because if you go down each rabbit hole, then you'll never come out with a game. So just stick to the simplest things, and then when you need a better solution, a bigger solution, you can always go for it. Next to data structures, again, I think computer science has taught us a lot of fancy red, blue, green, self-balancing trees, and other things that I don't know about. But again, like in 99% of cases, all you need is a array list and a hash map. You don't need things more complicated than that. And when you need them, you can use them, but like default to the simple things, right? And algorithms are the same. That linearly going through things is actually very fast, especially in games when you know your constraints. This big O of n is like this specter that looms over computer science, but when your n is 20, then n cube is 800, and like computer can do 800 in a frame. It's not an issue. So like keep the algorithms simple, mostly because then they become easy to edit, and it allows you to make your game faster, right? It allows you to make changes faster, keep track of things faster, because more detailed data structures and algorithms also impose constraints on the rest of the game, which is probably something that you don't want to be doing, right? So as long as that's kept simple, then it makes things a lot easier to work on. So the second one is specific. So keep it specific, stupid. And the first thing to learn is to profile. I think as developers, we gain a sixth sense for what is performant and what's not. And it's a terrible sixth sense, at least mine is absolutely terrible. I think I know what is inefficient, but even once I start profiling, I realize that that does not even show up on the profiler. The actual problem is somewhere else. So make sure that you're profiling, like especially when you care about things like size and performance. Like profiling is very important. So don't start solving problems that other people have. Profile your own game, your own tools, and then see where the problems are, and then fix them. So yeah, the second part is about solving problems. That every technical solution exists to solve a certain problem, and that problem may or may not be technical. It might be just interpersonal. It might be some limitation of the hardware which you are not using, and similarly, but each solution just sounds so like juicy, and as tech people, we love to try and use those solutions which don't make sense, right? So make sure that you're solving your own problems and not somebody else's problems just because the solution sounds sexy. Third thing is like non-general, which is technically the same as specific, but again, like when you have a general purpose engine, it has to cater to general purpose needs. And that's why a lot of the decisions that a Godot takes are taken in that way, because they want to be general. And one story I have for this is about particle systems, that I had heard about particle systems. They were like this mythical thing that are super performant and super amazing, and you should always use them. And I thought that was because it was like some hardware acceleration that's happening. So I looked into OpenGL, I looked into Vulkan, but none of them mentioned anything. So then I went back and looked at somebody implement a particle system from scratch, and it was so simple, right? It was just like tightly packed arrays and tightly packed loops that operate on those arrays, and that's what an efficient thing is, because for me that was the obvious thing. And then I realized that since you have this general purpose tool that has to do everything, that means that the general it cannot also optimize for being efficient. And that's the reason that you have separate efficient systems and non-efficient systems. So when you are specific, then you don't have to face that same problem. Everything can be at least like baseline efficient, and you don't have to add things that will slow down your game and your program because somebody else is adding them. So another example is pipelines. So in my case, my game has no pipelines because it doesn't need pipelines. Like pipelines exist when you have a different artist and a different engineer and a different technical artist, and the three of them have to work together. In this case, I was all three. So like my tools are all in code, and I sometimes change art by opening JSON files in Notepad. So like again, like it's a specific problem, but I didn't face it, so I didn't have to solve it. And this is like, the frame bus is a concept from Mario speedrunning, where there is no reason to go, let's bring it back to games. So the frame is how long it takes to process or how fast your monitor is updating. So if you have a 60 FPS game, then you have to update in 16 milliseconds. So if you are at 18 milliseconds, then saving 4 milliseconds helps. But if you're at 14 milliseconds, then it doesn't help, right? So make sure that your optimizations and your effort is going in the correct place. That if you're already under your frame bus, if you're already running at 60 FPS or 144 FPS or whatever your FPS might be, then adding more code to optimize things doesn't actually help your game. It wastes your effort. And while there is a case to be made that more frame time means, like more free time in the frame means more can be added, like that's not a problem that I faced. I was already short on time and I didn't have more things to add in the frame. So I did not benefit from saving a couple of milliseconds per frame by putting in a lot of effort. Rather, I realized that I'm already running under 3 milliseconds per frame. It's okay. I don't need to optimize anything. And finally, the last case is keep it smiling, stupid. Like at the end of the day, we are making games, and most of us do this out of a passion. So like if you think you really would like to embed a fancy scripting language into your game because it sounds fun, then like do it, right? Like enjoy yourself, splurge and spoil yourself. We do this because we enjoy it. Like we enjoy writing tech, we enjoy creating tech. And if you are not smiling and doing things that you would enjoy, then maybe you need to look at it again. So that was about my handcrafted engine. So the next question is why handcrafted engine, right? So I think we've not really reached this point yet, but it's because I'm lazy. And I know that sounds crazy that, oh, Sam, if you're lazy, then why are you doing so much work? But I think of lazy from a different direction, that like if you're trying to lose weight, then you don't keep gulab jamun in the fridge. So the same way, I know that I want to make unique things. And if I have access to a drag and drop third-person controller or a toon shader or something like that, I'm going to use it, right? I know that I'm lazy and I'm not going to do the work myself. So forcing myself to do everything from scratch allows me to make unique things. And I think that's, again, like a perk of my personality, but something that I am leaning into. Second, like process is precious. I think it's often, some people say like the journey is the reward. But it's the same idea. Like, have you ever seen anyone make a painting or compose a song? Like, it's such a beautiful process where they start off wanting to make something and they end up making something, and it may or may not be what they started off wanting to make. But the process of making the thing itself like changes it. It makes it better. Like if you're trying to draw a picture of a castle and then you draw rocks and the rocks look like clouds, then you're like, oh, let me draw a floating castle. And that's so much cooler. And the same thing happens in the game, right? Like how many bugs become features? How many stories of there are that? So for me, the way I see it, the whole process is making all of the tech allows you more moments to find magic like that. And that's something that I find very valuable. And like, yeah, like, so the secret I told you guys before, I really love writing code, so I think that's the correct way for me to go through these things. So that was, yeah, why I use the handcrafted engine. But I think the next question is like, why handcrafted? I think that why am I not aiming to make something that's awe-inspiring or beautiful or high quality? And I realized that I don't know how to make a high quality thing, right? I just know how to put myself completely into the things that I make and make sure that all of my effort goes into making the best thing I can. And that is a very precious thing, right? So they say history rhymes. So like textiles used to all be hand woven, but now once machines came along, they made textiles both cheaper and less with less flaws. But hand woven textiles still exist, and paintings used to be the only way to look at things that are realistic. But once photography came around, then paintings didn't go away, right? Paintings were now like free to be whatever they wanted to be, whatever they needed to be, express different things that only paintings can, right? So like we live in a time where a lot of things are changing, but some things don't change, right? Like putting a large amount of work into the things that you do will never lose its value. Telling your story in your voice does not lose its value, and attempting to create beauty does not lose its value, right? So I think that that's why I make handcrafted. And when it comes to handcrafted games, I don't think handcrafted games mean that you have to use your own engine or write your own tools. That's just like my way of creatively expressing myself. That I think I can give my best self when I use this path, but maybe that's not true for others. Like maybe other people can do this through design or through art or through production or through some other means that is not available. But I think the important thing about games like this is that a real person has thought a real feeling and has put it into the game, right? And as I asked you in the beginning, asked some of you in the beginning, like what was a moment that really made you feel? And that's because of this, right? That means that somebody cared enough to make a moment for you to experience through a game and play. And I think that's something that's really valuable today. And I believe that putting all of your effort into your work is always going to be valuable, and it might be the only way to make like great and special things. Thanks. Yeah, does anybody?
I guess we'll open for questions. Are there anyone? Please raise your hands.
Yeah, hi. Great talk. So now that you'll be moving on to newer games, what part of the handcrafted engine that you use right now goes into the other parts, or do you start from scratch? And what happens when you're prototyping? Because one would throw away so many ideas when you're making games, right? So.
Yeah, so I think along with making a game, I also learned a lot about making a game. So the next game is still going to be a custom engine, but it's going to be a product of everything that I learned as well. And prototyping for me is as much about prototyping game mechanics as engine architectures. So I kind of like use that opportunity to try out both things and see what works well for me. So that's how I look at prototyping, that if I want to try out a different architecture or a different way to process games, then I can do that in my prototypes as well. Thank you.
Any more?
Hi. What exactly did you benefit from using Zig over C? But because C is as simple as it gets, right?
Yeah, so I love C, but I think that C is also a very old language. So I find things like not having namespaces, like having namespaces is a feature that I admire. Then things like having a concept of a slice, which is like a pointer into memory with a length, that's useful. Then not needing header files, or like in C, sometimes things don't compile correctly if your header files are ordered wrong. Things like that, like things that are no longer problems that our computers face. Those are the kind of problems that Zig has solved in my eyes. And that's like I would have written it in C, but some of these things really bit me. And also the build system for C is like very convoluted sometimes, and Zig has like at least cleaned that up a bit. So that's why I like Zig.
Good afternoon. My name is Dhruv. Right. So by extension of his question, then why not Rust?
Again, like I think first of all, I like C because of its simplicity, and Rust I don't think has that same simplicity. And also for me specifically, the compilation speed of Rust is not fast enough. That I like to have like really rapid prototypes, especially when you're making art and things that if you want to change a few variables and you want to recompile it. If it takes like 30 seconds, that's not no go for me. So I've tried Rust in the past, but I didn't enjoy it specifically for that reason.
Awesome. I think we'll wrap up because we are running out of time and it'll probably overlap with the next talk. It was really interesting.
Thank you guys. Thank you everybody.
Yeah. It was interesting to know that you like coding more than actually making games. So.
Secret.
But yeah, so I think we'll prepare for the next talk, which is fireside chat, if I'm not wrong. So yeah.